DC motors are used inside everything from electrical toys to industrial machines. Let's take a look inside one to understand how it turns electrical energy into movement. The voltage supply is the energy source for the motor, like a battery or a DC power supply. When we connect it, current begins to flow through the circuit and into the coil. The higher the voltage, the higher the current. And that has a big effect on the motor's performance, which we'll see later. The split ring commutator is a clever part that ensures that the direction of the current in the coil reverses every half turn. That means the magnet forces always push the coil in the same rotational direction, allowing continuous rotation. Without the commutator, the motor will just lock back and forth instead of spinning. The coil or the armature is made from insulated copper wire, wound around a soft iron core. When current flows through it, it experiences a force due to the magnetic field, thanks to the motor's effect. This is what actually rotates. And the attached shaft can do useful mechanical work like spinning a fan or driving wheels. These are the fixed magnets, usually one north and one south. They create a magnetic field across the coil. When the current flows in the coil, it interacts with this field, producing a force on either side of the coil and causing it to turn. Increasing the current increases the force acting on the coil. That's because the motor force is directly proportional to both the magnetic field and the current, according to the equation of the magnetic force on a current-carrying wire. F equals nibble. So, if the voltage is increased, current increases. That means a stronger magnetic force acts on the coil and the motor spins faster. But there's a catch. Higher current also increases resistance heating and causes sparking at the brushes and commutator, something you'll notice in the next clip. At 2 volts, the current is small. The coil experiences a force, but it's weaker, so the motor spins slowly. You can see the motion is smooth and there is no sparking. The brushes and the commutator are operating cleanly because the current isn't high enough to cause damage. Now we've increased the voltage to 6 volts. That boosts the current, and as a result, the magnetic force on the coil is much stronger. The coil spins faster, which means the motor does more work, but notice the sparks. Those happen because high current causes arcing at the commutator. Over time, this can damage the motor, especially the brushes. So while increasing current improves speed and torque, it also introduces problems like overheating and wear.